Okay, in this one now we're going to consider A21 Physics 6 from June 2005. This is question 1 from paper 6 in June 2005, and it talks about the nucleus of the helium atom containing 2 neutrons, 2 protons, and it talks about the 2 types of force which predominate between these 2 particles. And then it just asks you to name the types of force and state the particles between which they act. So we're looking here, inside the nucleus you've got, it's a helium atom, so you've got neutrons and protons. So we're trying to identify the type of force which goes between protons and between neutrons. So first of all, the type of force is we've got the electromagnetic force. And which particles does it act between? It acts between protons. Why is that? Well, that's because protons are charged, neutrons are not, therefore they don't experience the electromagnetic force. However, why are the neutrons held in there? That's because they interact with the strong nuclear force. So the second force that we identify there is the strong nuclear force. And that strong nuclear force then acts between protons and neutrons. Or you could combine those together and say it acts between nucleons. So both protons and neutrons, and that's important because that's what holds neutrons into the nucleus. Otherwise the repulsion between the protons would overwhelm that and it would disintegrate. Right. Stable nucleus such as helium is in equilibrium state. What does this tell us about the forces? So that tells us that the forces acting must be balanced in some way. And hence cancel each other out. And the final part of this question refers to the fact that the helium nucleus is very stable, however very massive nuclei are not as stable. So in terms of the nuclear force, explain why this is so. Now this is because the strong force acts over a very short range. So the strong force has a very short range. And that means that adjacent particles are held together. Okay? So that holding adjacent, I could spell, holding adjacent nucleons together. But in a more massive nucleus, the protons are further apart. Sorry, the nucleons are further apart. And so what happens is that most of the protons are repelling. So the ones that are close together, so if you have a proton and a proton here, because they're positively charged and positively charged, you would expect them to repel. They don't repel then because this strong nuclear force holds it together. But as soon as you put this here alongside that plus that is causing a bigger force, and the strong force isn't enough to overcome that repulsion because it only acts over a very short interaction. And so here we have this, the short range nature of that strong force means that heavy nuclei with the more protons, more of them are being repelled. And that's the end of that question.